Okay, so now we're going to do a problem. This one right here. Just to illustrate these double angle identities. This is problem number 6 that we're going to do. It says, use this figure to find the exact value of the trig function. So sine 2 theta, well, sine 2 theta is, you know what? To find sine 2 theta, I don't need to be looking at those other things. I'm just going to look at this. Sine 2 theta, that would be 2 sine theta times cosine theta. It's been a while since we've done anything with our right triangles. You look at this right triangle here to figure out sine theta and cosine theta. What would we have? Remember, with your right triangle, there's your angle theta. So sine is 12 over 15, opposite over hypotenuse. And cosine would be 9 over 15. You know what, and before I multiply all of that together, I think I'm going to go ahead and reduce that 12 over 15. I could divide above and below by 3 to get a 4 over 5. What about the 9 over 15? I could divide those by 3, 3 over 5. And then thinking of that too is 2 over 1, just multiplying straight across. 2 times 4 times 3, is that going to be a 24 over 25? Any questions there? See what I did? Could y'all do the next one? Tangent 2 theta. Well, if we're going to find tangent 2 theta, that would be the 2 tangent theta over 1 minus tangent square theta. Ooh, maybe I better. So I've written down the identity. Let me lift this up so you can see it better. So in terms of this right triangle, tangent is opposite over adjacent. So tangent theta is 6 over 8. Let me go ahead and reduce that right now to what, a 3 over 4? So we have 2. In place of the tangent theta, I'm going to write 3 over 4. So 2 times 3 over 4, I guess I'll use parentheses for times, all over 1 minus tangent square theta. Let's just go ahead and square those right now and be done with it. The 3 over 4 times 3 over 4, 3 squared is 9, 4 squared is 16. And I'm running out of room. So I'll work it right here. Oh wow, the 2 times 3 over 4, here's how I'm going to go about it. I'm going to cancel the 2, saying 2 goes into 4 2 times. So up on top we would have 3 over 2. And on the bottom we have a 1 minus 9 over 16. If you want to rewrite the 9 as 16 over 16, or if you want to get rid of the complex fraction by multiplying above and below by what? What could I multiply above and below by that would get the 2 and 16 to cancel? Would 16 do it? Sort of a lazy man's way of doing this. 2 goes into 16 8 times. 3 times 4, excuse me, 3 times 8, 24. And on the bottom, 16 times 1 is 16 minus, what's 16 times 9 over 16? Is that just going to be a 9? Y'all ever seen fractions simplified like this? We'd have 24 over what? 7? Did y'all follow my manipulation there? Again, if you wanted to rewrite the 1 minus 9 over 16 as 16 over 16 minus 9 over 16 to get 7 over 16, 3 halves divided by 7 over 16, you'll still get 24 over 7 there. Okay. Now, let's do problem number, oddly enough, I don't know how this happened, but I think your number 1 in this assignment is 1 and 2 are probably some of the more involved ones. So let me see, where's problem number 1? Sort of leafing through. Oh, I know where it is. Just flip stuff. Okay, so, are we ready to move on?
Yes.
This is going to be number 1, and I'm warning you right now, it's going to take a little bit of work. Okay, this is problem number 1. And, oh, let me go ahead and lift this up. I'll just write down the identities we need as it goes through. It says, use identities to find the values of sine and cosine for the following angle measure. So saying find sine theta and find cosine theta. And here's what we're given. We're given that cosine 2 theta is 28 over 53. Oh, it couldn't be small numbers, could it? Okay. 28 over 53. And theta is in quadrant 1. This is an example of one of those problems you probably wanted to use your calculator on and probably wind up as a take-home problem, okay, rather than a in-class problem. Okay, so we're trying to find sine theta and cosine theta. And what we're given is this cosine 2 theta. So that sort of brings to mind the double angle identities, okay, sort of for cosine. Since we're told cosine 2 theta equals. So what we're going to do, let's first of all try to solve for, what does it say, find sine theta? Okay, so let's find sine theta. Given that cosine 2 theta is 28 over 53. And I might just wind up just showing it to you, but once you see it, you'll be able to do the next one, I think. We have 3 identities for cosine 2 theta. If I'm trying to find sine theta, which one of these would I replace this cosine 2 theta with? You see, I have cosine 2 theta equals 28 over 53. Which one of these, I'm going to write them in pencil because only one of them is appropriate. Which one of these could I use to solve for sine theta? If I wrote this, if I replace cosine 2 theta with cosine squared theta minus sine squared theta, could I then solve for sine theta and get a number here? Well, no, because of that cosine squared theta there. What if I use this one? 2 cosine squared theta minus 1. Oops, I wrote a 58 right here. It should be 53. I'm glad I'm using pencil. 53. See, like this one, I could solve for cosine here, couldn't I? But, so that's how I would do this next part. To find cosine theta. But to find sine theta, if I replaced this red cosine 2 theta, if I replaced it with 1 minus 2 sine squared theta, Then I have equals 28 over 53. It might be a little messy to go through it and solve that for sine for sine theta, but it's doable. Okay. Oh, there's one thing I overlooked in the problem. Oh, no, I didn't. I've written it down. Okay, I was about to say I didn't write down about the quadrant 1, but yes, I did. Okay. So I'm going to solve this equation for sine theta. It's going to be a little messy, okay? And it's a matter of whether you want to work with the fractions or not. I think what I'm going to do is multiply straight through by what to get rid of this denominator? 53. So I'm multiplying straight through by 53. And that would give me a 53 minus 106 sine squared theta. Now, if you're sitting there thinking, oh, wow, or watching this video thinking, oh, wow, that man can't work with fractions, just remember, my first name is Timothy Priscilla, okay? So multiply through by 53, gets rid of those fractions. It's going to fall up pretty easily now. Subtract 53. So we have a negative 106 sine squared theta equals, I'm going to move up. Let's see, 28 minus 53, is that a negative what? 25? Oh gosh. Divide both sides by negative 106? Ugh. So we have sine squared theta is a positive 25 over 106. And to get sine theta, we're going to have to take a square root. Which square root of sine? If we're in quadrant 1, theta's in quadrant 1, will sine be positive or negative? Positive. So we're going to take the positive square root. So sine theta equals positive square root of 25 over 106. It just couldn't be small numbers, could it? 5 over the square root of 106. And I sure don't think that square root of 106 simplifies, does it? So I'm not sure if they want us to rationalize on here or not. If they did, I guess multiply above and below by square root of 106. So here it is. Sine theta equals 5 square root of 106 all over 106. And this is problem number 1. Yours are going to have different numbers, right? This is one, but I can just change that 28 over 53. Oh, and let me write the answer right there. It's 5 square root of 106 over 106. And when y'all print out the problems, it doesn't show y'all the answers, but, oh, here it says rationalize the denominator. There have been some problems this semester where if you didn't rationalize, it would still take it, but I'm thinking this is one where it wants it rationalized. Okay. Now to do the second part, find cosine theta. Well, you're going to do the same thing we did here, except which one of the 3 identities would we use? Cosine squared theta minus sine squared theta, 2 cosine squared theta minus 1, or 1 minus 2 sine squared theta?
1 minus 2 cosine.
Yeah. You're going to use the one as the cosine, so we're going to solve 2 cosine squared theta minus 1 equals 28 over 53. Look at a clean sheet of paper. Right here. So, 2 cosine squared theta minus 1 is 28 over 53. Would y'all multiply through by 53? Yeah, I think I'm going to since I've already told you I'm Timothy Drusella, then, you know, I may as well continue with getting rid of the fractions. So it's, or the fraction, 106 cosine squared theta minus 53 equals 28. Ooh, how'd that get slanted? I will move the 53 over by adding 53. Let's see, what's that going to be, 81? Then divide both sides by 106. So we have cosine squared theta is 81 over 106. Take a square root to get just cosine. And are we going to take the positive square root or the negative? Let's see, we're in quadrant 1. Theta's in quadrant 1. So in quadrant 1, cosine and sine and tangent, all the trig functions are positive. So the square root of 81 over 106, that'll be 9 over the square root of 106. And could y'all rationalize it without too much trouble? Multiply above and below by the square root of 106. So we have 9 square root of 106 all over 106. Now those numbers are strange and you might be thinking, oh, they're not right, you messed up. But no, I didn't. When teachers print these out, they print the answer out. Isn't that sort of funny? Okay? I used to think that was sort of funny. The teacher books had the answers and stuff. I was like, oh, wow. But, yeah, now I know why. I'm confident I didn't mess up with any of the multiplying or adding. Okay? And that's problem number 1 there.